In this last video of Unit 5, I'm going to discuss the notion of a theorem. We'll see that theorems will be important and we'll be doing various things with them. Today I just want to say a little bit about what they are. So what's a theorem? Well, here are some examples. If P then P is a theorem, and if P then Q then not P is also a theorem. So what is a theorem? It's a sentence that it's true in every situation, and why is that? Because of its logical form. So take the first one, if P then P. Well, either P is true or P is false. If P is false, the antecedent of the conditional is false, and so the whole conditional is true, as we'll see. On the other hand, if P is true, then the consequent is true, and so again the conditional is true. How about the second one? Well, if suppose P then Q is true, and suppose that not Q is also true, that means you have a conditional with a false consequent. That means the antecedent also has to be false, so not P is true. So yes, indeed, if P then Q, then not P, no matter what. It's a sentence that's true in every situation, no matter what. These are sometimes called tautologies. It's also derivable from no premises. You may have noticed already that some of the derivations you've done have been derivations of arguments that did not contain any premises, that were just a conclusion. So those were all derivations of theorems. So here are a couple of important theorems. So the second one we already saw, if P then Q, then not P. Second is an analog of something I discussed in the previous relevance lecture, namely if Q, then if P, then Q. Another one also from that is if not P, then if P, then Q. And those are important to characterize the conditional. I'll talk about those in the next unit. And then we also have if P, then if not Q, then not if P, then Q. And if not Q, then P. And also if not P, then Q, then not Q. You'll note that along the side of these there are some numbers, so T13, T2, and so on. These are the numbers that the derivation module uses, assigns to the theorems, and if you go into the derivations module and you go to 1.1 or 1.2, you'll see a list of a whole bunch of theorems. So why are these particular theorems important? I'll be talking about that as we proceed. There are a couple of different things we can do with theorems once we prove them. One is that if you derive a theorem, it turns out that you can then write it down in any derivation you want by citing the theorem number. So if you derive theorem 2, then you go into some other derivation and you can write down theorem 2 whenever you want, and the justification is just T2. We'll also see that theorems enable what we are going to call derived rules. So we're going to be adding inference rules. When we get to chapter 2, we're going to add inference. We're going to add some more symbols to our language, and we will add inference rules that govern those new symbols. But we also will be adding more rules for our old symbols, what we call derived rules, and those are enabled by proving theorems. And if you want to mess around with those, you're welcome to, but you don't need to be doing just fine in the derivation system. I'll be talking about them later. So that's just a brief introduction to theorems. Remember, again, a theorem is a sentence that is derivable from no premises, and it's also a sentence that is true in any situation whatsoever because of its logical form. It's necessarily true, not just happenstance, right? My shirt right now is blue, but it's contingent that I'm wearing a blue shirt. I might have been wearing a red shirt. I'm not, but I might have been. It's not a theorem that I'm wearing a red shirt. It is a theorem that if I'm wearing a red shirt, then I'm wearing a red shirt. So, good luck with the homework. If you have any questions, let me know on the discussion boards or in office hours. And thanks for your attention.